In this video, we're going to solve equations that are quadratic in form. Equations that are quadratic in form. And just as a review, remember we said that a quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. All right. So what we're going to find out is that there are some equations that are not written exactly as ax squared plus bx plus c equals 0 that we can actually solve just like this type of equation. And what we're going to do is we're going to use the method that we call U substitution. What we're going to be able to do is we're going to be able to rewrite whatever equation that we're given in the form au squared plus bu plus c equals 0. So instead of writing our equation in terms of x, we'll write our equation in terms of u. The thing that makes this work is by noticing a pattern with our variables x. Okay? If you notice, this leading term, which has a degree of 2, has double the degree of this middle term right here, which is that bx, which has a degree of 1, right? Any equation that I have that has 3 terms and the leading term has double the degree or the exponent as the middle term, then I can write that as a quadratic equation, all right, using U substitution. And so let's look at an example here. I have x to the 4th plus 8x squared minus 9 equals 0. As you can see, I have that double thing going on, right? X to the 4th is double, right? X squared, right? If I multiply x squared by itself, I get x to the 4th. Just like if I multiply this x up here by itself, I'll get x squared, all right? And so that is a sign, and then I have my constant term, which is that minus 9 there. That's a sign that I can use. This is quadratic in form. And so what I'm going to do when I say U substitution is I'm going to let my U, which I create out of the blue, be that single term, which is that x squared. I don't want it to be the double one. I want it to be the single one. And if this is always written in descending order, right, we got x to the 4th, then x squared in our constant term, then I'm always going to choose my middle term, right, to be my u, all right, or the variable part of that middle term. And so since u equals that, now I'm going to write something here, because if this is going to be a quadratic equation, I can write this as something squared. I'm going to use the same coefficient, which is 8 times something to the first power, we don't write the 1, minus 9 equals 0, all right? And that something that I'm going to write in those sets of parentheses there is that x squared, right? And I'm going to make sure that I have the same exact equation that I started with, which is here, right? When we square x squared, we still have x to the 4th. Plus 8x squared, well, that's what's sitting here. So these two are the same, and this minus 9 equals 0. Everything is the same. So by letting u be x squared, I can now replace my u, or my x squareds, with u, and I have this as a quadratic equation. It's going to be u squared plus 8u minus 9 equals 0. And this is the equation that is quadratic now, right? And so I know a ton of methods that'll help me be able to solve this type of equation. You can factor, you can complete the square, you can use a quadratic formula. Since there's a 1 in front of the x squared, I'm going to automatically try to factor. See if that'll work for me. Put a u here, and 2 numbers that multiply to give you a negative 9 but add up to a positive 8. A positive 9 and a minus 1, or a negative 1 would work for us. Now that we have 2 things that multiply together to give us 0, we're going to set both of them equal to 0 to solve for x. All right, if I subtract 9 here, I'm going to get u equals negative 9. All right, and here if I add 1 to both sides, I'm going to get u equals a positive 1. All right, so I subtracted 9 from that left equation, and I added 1 to both sides of that equation on the right. Now, this is solved for u, right? When I first started this problem, I'm supposed to solve for x. Which x values can I plug in there and make that equation true? And so since I'm sorry for scrolling so much, since I know that u equals x squared, sorry about that. Since I know that u equals x squared here, I'm going to replace that u in this equation with x squared, and then that's going to help me solve for x. So instead of u equaling 9, I'm going to have x squared equaling, negative 9. And instead of u equaling 1, I'm going to have x squared equaling a positive 1. Okay? Now I can solve this equation for x by taking the square root of both sides. And so I'll get x equals, remember you have to put on plus or minus, and the square root of negative 9 is the same thing as 3 times I. Likewise, if I go to the second equation here and I take the square root of both sides, I'll get x equals, remember to put on your plus or minus, and the square root of 1 is 1. And so we get 4 solutions. We have 3i, we have 3i, negative 3i, 1, and negative 1. And then you can always check your solution by substituting those values in for x into your original equation. All right, so this is u substitution. All right, first we make sure this is in descending order. We let this middle x term, just the x part, the variable part, be our u. We substituted u into our equation. Remember, this step right here isn't a necessary step. I just wanted you to know that it does work. All right, when you write it like that, you can really see what your u is going to equal. And then we got our equation in terms of u. We solved it for u. Then we changed it back in terms of x. And then we solved for x. And then again, I'll let you check your solutions on your own. If you want to write some steps, this is some steps that you'll always be able to use to help you do that. It says write equation in descending order. Set the middle variable equal to u with its exponent, right? So include the exponent. So if the exponent is 1, of course you're just gonna, it's quadratic if it's 1, but include the exponent or whatever sign you see with it. Not negative or positive, but just include the exponent with it. Substitute u in for all terms in the equation, and then solve for u. You're gonna back substitute to get it back in terms of x. And then you're gonna have to go and solve for x, and then check your solution. Let's look at another example. In this example, we have x minus 7 square root of x minus 30 equals 0. Okay? Now, at first sight, this may not look like it can be written in quadratic form. But you have to remember that the square root of x is the same thing as x to the 1/2 power. So we have x to the first power here, 7x to the 1/2 power here, and then minus 30. So remember, right, I have x to the 1/2, right? If I multiply x to the 1/2 by itself, I will get this x to the first power here. So I've got that double power thing going on once again. And so since this is in descending order, I'm going to let this middle variable part be my u. So I'm going to let u equal the square root of x. Okay? With that being said, again, to show you why this works, right? If I take the square root of x and square it, I get the same thing as x, all right? Minus 7 times the square root of x minus 30 equals 0. Now, what you might be thinking is, well, when I take the square root of x and square it, that might be causing some issues with signs, right? And so we're going to have to really check our solution once we do this equation here. But in any account, we just figured out what u is supposed to be. So instead of writing this as square root of x, I'm going to now write it in terms of u. So I'll get a u squared minus 7u minus 30 equals 0. And again, we're going to solve this quadratic equation for u and then get it back in terms for x by using this thing right here. All right? And so I'm going to do that. I'm going to try to factor again. Again, you can use the quadratic formula if you're more comfortable with that. You can complete the square and extract square roots. Okay. I want to find two numbers that multiply to give me this negative 30 here to add up to negative 7. Those two numbers will be a negative 10 and a positive 3. So we have two things that multiply to give us 0. So we're going to set both of them equal to 0 to get both of our solutions. All right, and I'm going to add 10 to both sides to this equation on the left. I'll get u equals a positive 10. And on the right-hand side, I'll subtract 3 from both sides, and I'll get u equals a negative 3. And so this would be considered my solutions in terms of u. What we want to do is have our solutions in terms of x, and so we're going to have to remember that we let u equals the square root of x. So if I want to solve these equations for x, I'm going to replace u with the square root of x, so I get the square root of x equals 10, and on this equation to the right, I get the square root of x equals negative 3. Okay. To solve these equations for x, we need to square both sides to get rid of that square root. So when I square both sides here, I get x equals 100. And similarly, all right, now some of you may see a red flag here. We have a square root of x equaling a negative. And way back in chapter 9, we said that a principal square root will always be equal to a positive value. And the only way it's going to equal to a negative is if there's a negative on the outside. But since there isn't a negative on the outside, right, I just put that there to make animation, then I know that I'm not going to get a solution for this one here, all right? If you're not able to catch that or understand that, then go ahead and square both sides, but always make sure that you check your solutions at the end, all right? And I'm going to go through the process of how we check our solutions. Square both sides, negative 3 squared will be 9, okay? I'm going to check that x equals 9 is my solution. That means I'm going to plug in 9 for x into my original equation here. I have x minus 7 square root of x minus 30 equals 0. I'm going to plug in 9 for x. So I get 9 minus 7 times the square root of 9 minus 30, and I'm checking to see if that equals 0. Well, the square root of 9 is 3, and so I get 7 times 3. And 7 times 3 is 21, so I get a minus 21 minus 30. That definitely does not equal 0, too much negative stuff. So again, we see that x equals 9 is not our solution. All right, now x equals 100, you can check that solution as well. I'll allow you to do it on your own time. Just plug it in for x, and what you're going to see is that x equals 100 is your solution. And so we get just one solution for this equation, which includes 100. So that is our solution set. Okay, we're going to look at one more example like this. And it is an example that looks like this, right? We have all fractional or rational exponents, x to the 2/3 plus 4x to the 1/3 minus 32 equals 0, all right? Notice that my equation is in descending order. My highest power is first, then I go down by my next lowest power of x, and then I have my constant term. And if you notice, I do have a quadratic form, right? X to the 1/3, if I multiply it by itself or if I double it, I do get x to the 2/3, right? And so that is a sign that this x to the 1/3 is going to be our u. So what I'm going to do is I'm going to let u equal x to the 1/3. And again, with this, I want to show you why it happens, right? So if I do x to the 1/3 and I square it, right? When you raise a power to a power, remember, and these are fractions, so this is like saying 2 over 1. When I multiply the 1 by 2, which I get that 2 up there, and I multiply the 3 times 1, which is I get that 3 down there. So this is the same thing as saying x to the 2/3, right? And I have plus my 4 times x to the 1/3 minus 32 equals 0. And as you can see, once again, I'm going to replace my x to the 1/3. Looks a little weird there. That's why I don't like writing it like that. But my x to the 1/3 is going to be replaced by u. And so my equation is going to become u squared plus 4u minus 32 equals 0. And then we go through that same process. You can factor. You can use the quadratic formula. You can use completing the square and extracting square roots to help you solve this equation. Once again, I'm going to factor. I think it's a little quicker for these types of examples. Now, when you get to your homework, you may see some examples where you have to use one of those other methods. But since you already know how to do those methods, it's not that important for me to do it in this video. All right. But I factor that. I want two numbers that multiply to give me negative 32 added to a positive 4. 8 and negative 4 definitely work. I have my two things that multiply together to give me 0. So I'm going to set them both equal to 0 to solve for x. Sorry, I'm going to solve for u first. Right? U plus 8 equals 0. Let's subtract 8 from both sides. We'll get that u equals negative 8. And the u minus 4 equals 0. Let's add 4 to both sides. We'll see that u equals a positive 4. In order to solve for u, we got to, well, we've already solved for u, actually. We've isolated u now, and now we want to get everything in terms of x. So I go back to my statement where I assigned my variable u. I said that u equals the x to the 1/3 power. And so what I'm going to do here is I'm going to say x to the 1/3 equals negative 8, and x to the 1/3 equals a positive 4. All right, and that's an equal sign. Don't want you to confuse that with a not equal sign. And for me to solve for x, remember, this is the same thing as taking the cube root, right? And when we take the cube root of something, in order to get the x, or the radical by itself, radicand by itself, we raise it to the 3rd power. So I'm going to raise both sides to the 3rd power, okay? Here, I get x by itself, and negative 8 times negative 8 times negative 8 is negative 512. And I do the same thing to this equation here, raise both sides to the 3rd power, and I get x equals 64, okay? I'll allow you to go through the process where you plug those values in for x and check your solution, and you will see that both of those are, in fact, a solution to this equation, and so we'll have both of these as our solution, okay? And this concludes our video on equations that are quadratic in form.